In this video, I will be explaining you one of the problems that you can see in Strum Liouville's problems section. Okay, so here you can see the statement. You can say statement or question. Okay, from this Strum Liouville's problem. So let me read the question. Determination of stationary values of the quantity lambda defined by the ratio this, where here you have P, Q, R. Okay, these are the functions of independent variables X. Okay, sometimes they may ask you derive Sturm Liouville's problem like that, or sometimes they maybe give you this question and ask you to write the answer. So whatever it might be the case, you have to be ready for both cases. Okay. Let me start writing the solution. So here you can see my notes. Okay, this is the statement. I wrote it as a statement. Okay, get ready with the statement also. So determination of lambda is defined by like this. Okay, lambda is equal to this value and this value will be equal to I1 by I2, where here you have P, Q, R. These are the functions of independent variable X. Okay, that is how you have to write the statement. Now here what you are doing is, first you are taking let lambda is equal to I1 by I2. You are taking lambda is equal to I1 by I2. Okay, so now you are finding delta lambda. Okay, so that multiply delta with this, multiply delta to this lambda so that you will get this. Okay, after that you are differentiating in u by v format. You know that how to differentiate in u by v format. Denominator square. Okay, the value in the denominator square. Okay, that value square. Then denominator value v du minus numerator value u dv. Okay, this is what the format. Okay, in that format you are going to differentiate this so that you will get this. From this you are just splitting it so that you will get this. The reason for splitting it is you are going to cancel it. The process, if you want to do this process, then splitting will make that easy. Okay, otherwise here some of the confusions may arise. So that is why I have wrote each and every steps. So from this here you have cancelled so that you will get this step. So from this you can take 1 by I2 common. So after taking 1 by I2 common, you will get this. So here we know that I1 by I2, the value of I1 by I2 is lambda. So just put lambda. So here you got delta lambda value. Now what we are going to do is, we are going to substitute the value of I2, delta I1 and delta I2 values in this equation. So if you want to substitute that, you have to find it right first. Right. So what you are doing is, first you are taking I1. If you have the value of I1, then using that we can find delta I1. Also, if we have the value of I2, then using that you can find delta I2 easily, right? So that is what we are going to do now. So first let I1 equal to, you are taking I1, the numerator value was I1. Let I1 equal to this, right? Okay, write it. And then you are finding delta I1. So just multiply delta with this I1 so that you will get this. Now what you are doing is, you are multiplying this delta inside so that you will get this. Okay, now you are splitting the terms. Okay, you are multiplying this delta dx, integral dx to both the terms so that you will get this. Okay, now what you are doing is, you are going to integrate this in udv format. You are considering this as u and this as dv. Okay, you should not disturb this term. Keep this term as it is. Here you are going to integrate this term only. Okay, in udv format. Okay, is that clear? Okay, let me turn the next page. Okay, in this page here you are integrated it u dv minus integral v du, like that you have you have integrated and you are writing this term as it is. Okay, like in the previous step. Now from this what you are doing is, from these two terms you can take this integral and delta y dx common. So you have took that common. You not only took integration and delta y dx common, you also took this minus also common, so that you will get this. Okay, you are taking minus integral a to b delta y dx common, so that you will get this. Now you are you are going to find the value of delta I2. If you want, as I told you earlier, if you want the value of delta I2, first you have to choose I2, right? So that is what you are doing. Let I2 is equal to this. Here you can see delta I2. Just multiply delta I2, just multiply delta with I2. Okay, so that you will get this. Now you got I2 value, delta I1 value and delta I2 value. Just substitute the values in this equation number 1. Okay, just substitute the values in equation number 1, so that you will get this. Okay, now put delta. Here is a constraint. This is one of the constraints. Okay, so you are putting the value delta lambda is equal to 0. Okay, after putting this you will get this. This becomes like this. Okay, this becomes, when it comes to the opposite side, equal to other side, then this will cancel, so you will get only this term. Okay, so this values, so you are writing that. Now from this what you are doing is, you are writing this as it is. Here you are taking minus integral a to b delta y dx common from these two terms, so that you will get this. You are taking minus also common, so that here you have to be you have to concentrate. Okay, you may commit mistakes here in signs. Okay, so that you have to concentrate here. Now using this you are going to write the relevant Euler equation. Okay, you are writing relevant Euler equation from the coefficient of delta y dx. So you write this. This is your relevant Euler equation. This can be written like this. Okay, py dash the whole dash can be written like this, d by dx of this value plus qy plus lambda ry is equal to 0. Now from here you can write one of the boundary conditions, that is the coefficient of delta y is one of your boundary conditions. So just write it. The natural boundary conditions are py dash equal to 0 or y prescribed. Okay, this is how you will finish writing the solution of this statement or problem, whatever it might be.